Percent composition by mass is oftentimes used in the analysis of matter. It may come from using experimental data gathered from the field, or in the case of this segment, we're going to look at the formula for the compound and determine the percent composition from that. So the example we use is iron 3 carbonate. So the iron 3 would be Fe with the 3 plus, and carbonate being a 2 minus, the correct balance formula would be Fe2CO3 taken 3 times. Now, when you calculate the percent composition, it's very similar to calculating your percent on a test. If you calculate your percent on a test, you're really calculating the percent correct, which is equal to the number correct divided by the total number of points possible times 100%. So if we wanted to figure out the percent iron by mass in this compound, that would be the mass of the iron part divided by the mass of the whole compound times 100%. The dilemma we face now, though, is that we don't have an amount of iron or an amount of the compound to work with. So we've got to come up with that. The way we're going to do this is we're going to assume we have 1.0 moles. Okay? If we have 1 mole of the compound, then by looking at the formula for the compound, we would actually have 2 moles of iron, and each mole of iron having a mass of 55.85 grams would give us a mass of iron in that 1 mole of 111.7 grams. Continue on, 3 carbon atoms in the compound, 1 mole of the compound, 3 times 12.01 would give us 36.03 grams, and 9 moles of oxygen in 1 mole of the compound, 9 times 16, 144.0 grams. And then if we add all that together, we get 291.7 grams for the mass of the whole compound. So now we can come back over to our formula, and we can plug in the mass of the iron part, which would be 111.7 grams, the mass of the whole compound, 291.7 grams, times 100%, and that would give us a percent iron of 38.29%. Okay. Now, likewise, if you needed to calculate the percent carbon, you would use the mass of carbon over the total mass, and if you had to figure out the percent oxygen, you would use the mass of the oxygen divided by the total. If you go ahead and do those calculations, you should get percent carbon equaling to 12.35%, and the percent oxygen equal to 49.37%. So like anything else, probably need to practice a few of these to get them down. But yeah, the key here is recognizing your formula, plugging things in, and assuming that you have 1 mole. And you need to indicate that before you go down and calculate the masses of each of the elements.